Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss one of the important topic of the subject fluid mechanics and fluid machines, and the topic is types of flow. So, in this lecture, firstly, I will discuss what is flow. Then I will discuss different types of flow. Then I will conclude why it is important for study. So basically, what is flow? Basically, fluid flow refers to the motion of fluid substance like liquid and gases under the influence of different forces. What is the objective for study the introduction to flow? So, to classify different types of flow and understand their characteristics for effective analysis and engineering application, we will study this topic. Then, classification of flow. So, the fluid flow are classified into steady versus unsteady flow, uniform versus non-uniform flow, compressible versus incompressible flow, viscous versus non-viscous flow, laminar versus turbulent flow, 1, 2 and 3 dimensional flow, then rotational versus irrotational flow, then subsonic, sonic, supersonic and hypersonic flow, and lastly subcritical, critical and supercritical flow. In further slide, I will discuss in much detail what is steady, what is uniform, what is compressible versus incompressible and so on. So, the first classification is steady versus unsteady flow. What is steady flow? Fluid properties like velocity, pressure, density, etc. at a point do not change with time is called steady flow. For example, water flowing through a pipe at constant rate is the example of steady flow. Then what is unsteady flow? Fluid properties like velocity, pressure and density, etc. change with respect to time at a particular point is called unsteady flow. For example, water flow when a pump is started or stopped. So, mathematically we can say that for steady flow, del R over del T at particular point P is equal to 0, then this type of flow is called steady flow, where R is different properties, fluid properties like velocity, pressure and density. And if del R over del T at particular point P is not equal to 0, so we can say that this type of flow is called unsteady flow. Then the second type is uniform versus non-uniform flow. What is uniform flow? Flow parameters such as velocity and pressure are the same at every point in a given section and fixed time. Is called uniform flow. For example, water flowing at constant velocity through a straight pipe of constant diameter is the example of uniform flow. Then what is non-uniform flow? Flow parameters like velocity vary from point to point within the flow field at a particular time is called non-uniform flow. For example, water flowing through a pipe with varying diameter is the example of non-uniform flow. Mathematically, we can say that del V over del S at particular time t is equal to 0, then this type of flow is called uniform flow. And if del V over del S at particular time t is not equal to 0, then this type of flow is called non-uniform flow, where V is the velocity, S is the particular point, and T is the time. Then the third classification is compressible versus incompressible flow. What is compressible flow? Density of the fluid changes significantly under pressure and temperature variations are called compressible flow. For example, high speed air flow in jet engines is the example of compressible flow. Then what is incompressible flow? Density of the fluid remains nearly constant with respect to pressure and temperature is called incompressible flow. For example, flow of water in rivers and pipes is the example of incompressible flow. Mathematically, we can say that if density with respect to pressure is not equal to 0, then this type of flow is called compressible flow. If density with respect to pressure is equal to 0, then we can say that this type of flow is incompressible flow. Then next classification is viscous versus non-viscous flow. Non-viscous also known as ideal flow. What is viscous flow? Internal fluid friction due to viscosity. Real fluid exhibit viscous effect, means those type of fluid which have some viscosity, some internal resistance, it is called viscous flow. For example, oil flowing in a pipe. Then what is non-viscous ideal flow? Means no viscosity. Theoretically, concept used in the analysis, means those type of fluid which have zero viscosity is called non-viscous fluid. But in a real case, no fluid have zero viscosity, means this is the purely theoretical concept. So what is the examples of non-viscous assumed flow in Bernoulli's equation? So this is not a practical case, this is only hypothetical case. Okay, so this is viscous versus non-viscous. Then what is laminar versus turbulent flow? Laminar flow matlab fluid particles move in smooth layers or path without mixing, means कि fluid flow in a parallel path is called laminar flow. For example, it occurs at low Reynolds number, means Reynolds number is less than 2000 in a pipe, then this type of flow is called laminar flow. Flow of glycerin or honey in a tube are the example of laminar flow. What is turbulent flow? Fluid motion is chaotic and involves eddies and vortices, means कि there is a zigzag wave motion of the fluid particles, then this type of flow is called turbulent flow, and it occurs at high Reynolds number. If Reynolds number is greater than 4000 in a pipe, then this type of flow is called turbulent flow, like river water during floods are the example of turbulent flow. Then what is 1, 2 and 3 dimensional flow? One dimensional means 1D flow. If flow parameters vary only in one direction, typically along the length, then this type of flow is called 1D flow. Example, flow through a nozzle. Then what is 2-dimensional or 2D flow? Flow parameters vary in two directions, say x and y. Negligible variation in third, means in third direction, in z direction is negligible variation, then this type of flow is called 2-dimensional flow. For example, flow over a flat plate is the example of 2-dimensional flow. Then what is 3-dimensional, 3D flow? Flow parameters vary in all directions, say x, y and z. then this type of flow is called three-dimensional flow. Example, flow around an aircraft is the example of 3D flow. Then next classification is rotational versus irrotational flow. What is rotational flow? If fluid particles rotate about their own axis, then this type of flow is called rotational flow. But if fluid particles do not rotate about their own axis, then this type of flow is called irrotational flow. So the example of rotational flow is flow in a whirlpool. Whirlpool is the example of rotational flow, whereas ideal flow assumptions in potential flow theory is the example of irrotational flow. Then what is subsonic, sonic and supersonic and hypersonic flow? Firstly, before defining the subsonic, sonic, supersonic and hypersonic flow, first of all, I will discuss what is Mach number. Basically, Mach number denoted by symbol capital M is the ratio of flow velocity to the speed of sound. And Mach number is the ratio of flow velocity V divided by speed of the sound C. So if Mach number is less than 1, means the velocity of flow is less than velocity of sound, then in that case, if flow speed is less than speed of sound, then in this case the flow is called subsonic flow. For example, commercial airplane at cruising speed is the example of subsonic flow. What is sonic flow? If Mach number is 1, means flow speed equals to the speed of sound, then this type of flow is called sonic flow, like flow at nozzle throat. Then what is supersonic flow? If Mach number is greater than 1, means flow speed is greater than speed of sound, then this type of flow is called supersonic flow. For example, fighter jet. Then what is hypersonic flow? The very high speed flow, means if Mach number is greater than 5, then this type of flow is called hypersonic flow, like space re-entry vehicles are the examples of hypersonic flow. Then what is subcritical, critical and supercritical flow? So before starting the definition of subcritical, critical and supercritical flow, first of all I will discuss what is Froude number. So basically Froude number denoted by Fr is the ratio of inertial force to the gravitational flow. And Fr is the ratio of inertial force to the gravitational force. So if Froude number is less than 1, means slow truncular flow, gravity dominates, is called subcritical flow. Means if Froude number is less than 1, then the flow is called subcritical flow. If Froude number is equal to 1, means flow velocity equals to the wave velocity, then this type of flow is called critical flow. For example, flow at Weir crest. Then what is supercritical flow? If Froude number is greater than 1, means rapid shallow flow in inertia dominates are called supercritical flow. For example, water flowing down steep slope are the example of supercritical flow. Then what is the application of flow types? So the applications are in different domains like mechanical system, aerospace and hydraulics and biomedical. In mechanical system, pump, turbine, compressor design, steady and viscous flow. In aerospace, airplane and spacecraft design, Mach-based classification. In hydraulics, river flow, dam spillways, Froude number based. And in biomedical, blood flow in arteries, laminar versus turbulent. So these are the different applications of flow types. Then why it is important? Why study of flow classifications is important? So for proper classification of flow is essential for analyzing real world systems. Each flow type has unique equations and analysis methods. Understanding flow behavior enhances system efficiency and safety. So, this is all about for this lecture. Thank you.